Okay, a recurrent relation for the probabilities of binomial distribution. क्या करना है? We have to find a recurrent relation. Okay, as we know, the probability distribution for the binomial distribution is given by, as you know, p of x equal to p of x equals to x, that is equals to ncx p to the power x q to the power n minus x. Now knowing this, we want to find for p of x plus 1. Now what we can write? P of x plus 1 equal to p of x equals to x plus 1. What we have to do? We have to find a recurrence relation for the probabilities of binary distribution. That means simple, we want to find the relation between px and px plus 1. Okay. As you know, for binomial distribution, we have p of x equal to x as and cx p to the power x q to the n minus x. So for x plus 1, what you have to do? X as x plus 1. So nc x plus 1 p to the power x plus 1 q to the power n minus x plus 1. Okay. Now, what do we do? We simply do one calculation. P x plus 1 divided by px. Then that means px plus 1 divided by px. So we have ncx plus 1 p to the power x plus 1 q to the power n minus x minus 1 divided by ncx p to the power x q to the power n minus x. Okay. So doing this, you all know the formula corresponding to ncx. So this gives nothing but n factorial divided by x factorial. Okay, x plus 1. So we have x plus 1 factorial with n minus x minus 1 factorial p to the power x plus 1 and q to the power n minus x minus 1. And denominator will give n factorial divided by x factorial n minus x factorial with p to the power x q to the power n minus x. So by doing this, what we can see, look here. So just simplifying it, देखो क्या क्या कैंसिल हो रहा है. n factorial will cancel out, this n factorial cancel out. Here x plus 1 factorial x factorial, then यहाँ पे एक रहेगा x plus 1. Now n minus x minus 1 factorial, here n minus x. So ये कैंसिल होके ये बचेगा. So simple, and p to the power x plus 1. So यहाँ पे बचेगा p. ओके, यहाँ पे वो बचेगा p. यहाँ पे देखो n माइनस एक्स माइनस 1, यहाँ पे n माइनस एक्स है तो बचेगा नीचे q आएगा. एंड ऊपर देखो ये कैंसिल. नेक्स्ट, एज यू नो, ये डिवाइडेड बाय है ना, दिस बाय दिस डिवाइडेड बाय दिस बाय दिस, सो दिस बाय दिस इनटू होगा. देन ये सिंपल हमें क्या देगा? दिस विल गिव यू n माइनस एक्स divided by x plus 1. Okay, so what we got? This implies we got p of x plus 1, capital P, as n minus x divided by x plus 1 p by q, small p by q, with capital P of x. Okay, this is the recurrence relation for a binomial distribution. Clear? Clear और कुछ doubt है? Everyone, please.
Yes, sir.
लिखो नहीं तो इसको
Yes, sir.
snapshot लो. You write it or take the snapshot. ठीक है? Complete? Complete?
Yes, sir.
Complete? हाँ. Okay. Okay. Full class में. Hello.
Yes, sir.
Okay. Next part. Next part is, I'll spell it now better. Next part is our moment generating function. Moment generating function or you can say MGF. Okay, moment generating function of binomial distribution. What is that? What is moment generating function? Here, look here. Let x be a discrete random variable which follows the binomial distribution. Okay, then we want to write mx of t. x कहाँ पे है? x नीचे है, index. mx of t is expectation value of e to the power tx. Okay, and this equals to summation n from 0 to x from 0 to n e to the power tx n cx p to the power x q to the power n minus x. Okay, so this will be summation x equal to 0 to n p e to the power t to the power x with ncx q to the power n minus x. Okay, क्या लिख रहे हैं? ncx combination. Or simply in other way we can say moment generating function as, देखो, this is nothing but your q plus p e to the power t to the power n. Okay, q plus p e to the power t to the power n. Now the MGF about mean of binomial distribution. About mean, now you have to calculate. So for that one, what we take? Since the mean of binomial distribution is np, and what we have? We have expectation value of e to the power t into x minus np. This will be equals to expectation value of e to the power tx into e to the power minus np. Now you can take e to the power minus ntp outside and this gives e to the power tx, or simple is equal to e to the power minus tnp with this is nothing but your mxt. Okay. Now, as you have computed mxthq plus e to the power p, so just substitute here e to the power minus t and p multiply with q plus p e to the power t power n. Okay. Now, what you can see, this is equal to plus p e to the power n. So nn. Then by simplifying, what can I write? फिर क्लियर नहीं दिख रहा है ना? हेलो हेलो
Yes, sir. Clear नहीं दिख रहा है.
हेलो क्लियर दिख रहा है? नहीं दिख
नहीं
रहा है ना? थोड़ा वेट करो, आ जाएगा शायद. कुछ नहीं, नेटवर्क इशू है समथिंग. व्हाट कैन आई डू? बाद में इसका स्नैपशॉट ले लेना, ठीक है? कभी आएगा तो ठीक से. हाँ, अभी आया. ओके. सो एन एन पावर एक साथ, सो क्या करें? वी कैन राइट क्यू एन पावर है, दैट मीन्स दोनों को मल्टीप्लाई कर सकते हैं. क्यू e to the power minus tp plus p e to the power t into 1 minus p whole to the power n. Okay. So this equals to क्या होगा? q e to the power minus tp plus p e to the power t, देखो 1 minus p as q to the power n. Okay. Up to this clear? अप टू दिस क्लियर कि कुछ डाउट है? नाउ देखो, इसका फोटो ले लो. फर्स्ट दिस पार्ट, मोमेंट जनरेटिंग फंक्शन, इतना लो पहले. क्लियर?
Yes, sir.
क्लियर ही नहीं? नाउ इसको थोड़ा, ओके. नाउ एक्स्ट्रा क्या करें? इसका फोटो भी लो, सेकंड वाला, ये एमजीएफ रिफ्लेक्शन हो रहे हैं. हाँ, अभी आया. टेक द फोटो. क्लियर? नाउ देखो, यहाँ पे जो है e टू द पावर माइनस टी पी और यहाँ पे e टू द पावर टी क्यू, इसको अभी हम टेलर सीरीज एक्सपेंशन में करेंगे. ठीक है. सो नेक्स्ट हमें क्या मिलेगा? यहाँ पे मैं दे रहा हूँ. नेक्स्ट व्हाट यू गॉट? दिस इक्वल्स टू, ओके पेपर में देते हैं, बेटर होगा. नाउ इसके लिए मैं कैलकुलेट कर रहा हूँ. ठीक है. हमें क्या लेना है? देखो, q e टू द पावर माइनस टी पी प्लस p e टू द पावर टी क्यू टू द पावर n, ये कैलकुलेट करना. नहीं, अभी देखो ये कैसा दिखेगा, ध्यान से. नाउ दिस इक्वल्स टू q जैसा का वैसा. अब इसका सीरीज एक्सपेंशन 1 माइनस पी टी प्लस पी स्क्वायर टी स्क्वायर डिवाइडेड बाय 2 फैक्टोरियल प्लस पी क्यूब टी क्यूब डिवाइडेड बाय 3 फैक्टोरियल प्लस डॉट डॉट डॉट. ये किसके लिए? ये टर्म के लिए. प्लस सेकंड वाला p इंटू 1 प्लस क्यू टी प्लस क्यू स्क्वायर टी स्क्वायर डिवाइडेड बाय 2 फैक्टोरियल प्लस क्यू क्यूब टी क्यूब बाय 3 फैक्टोरियल प्लस डॉट डॉट डॉट. ये होने के बाद ये पूरा का पावर n. ओके. नाउ नाउ यहाँ पे p है, यहाँ पे q प्लस है, तो व्हाट कैन यू टेक, देखो ये आ जाएगा यहाँ पे q इंटू वन एंड p इंटू वन, सो दिस गिव्स p प्लस q एक जगह आ जाएगा प्लस, नेक्स्ट देखो, नेक्स्ट पी क्यू p square divided by 2 factorial, again p plus q plus pq, then tq by 3 factorial, again p plus q, q by 3 factorial, what you got, q square minus p square, power
सर फ्रीज हो गया सर, कैमरा आपका सर।
हेलो, फ्रीज हो गया, हाँ
सर
हे
नहीं
भगवान,
दिख रहा सर।
हाँ हेलो, नेटवर्क इशू और कुछ नहीं, बाकी पहले से अच्छा आ रहा था नहीं, आज का क्लास ऐसा हो रहा है। हाँ उसके बाद देखो p प्लस क्यू इक्वल टू वन हर जगह, सो दिस गिव्स वन प्लस NC1 NC1 bracket start PQ T square by 2 factorial P plus Q plus PQ TQ by 3 factorial Q square minus P square plus dot 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 plus NC2 similarly PQ T square by 2 factorial P plus Q plus PQ TQ by 3 factorial, again Q square minus P square प्लस ऐसा करके जाएगा ये होल स्क्वायर, प्लस ऐसा ऐसा करके NCN करके कब तक करना है, ये करना है n पावर तक, सो 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 what you get say from the above equation, from the above equation you can say mu2 equal to coefficient of t square by 2 factorial, that is npq, and mu3 equal to coefficient of tq by 3 factorial, that is npq q minus p. Okay, यह तुम्हारा मोमेंट जनरेटिंग फंक्शन अबाउट मीन, ठीक है। एक मिनट में इसको थोड़ा बंद करता हूँ। Okay, up to this clear? Now नेक्स्ट एक एग्जांपल करते हैं। ओके ओके, इसका फोटो ले लो। दिस फोटो, ठीक है। नेक्स्ट, ओके, एक एग्जांपल देखो what it says. One example, a set of 6 similar coin are tosses with following results. Okay, a coin of a set of 6 similar coin are tossed 640 times with the following results. What are the result? Here, number of heads. Hello. Hey everyone. A set of 6 similar coins are tossed with following number of heads here with frequency. 1, 64, 2, 3, 3, 210, 4, 132, 5, 75, and 6, 12. Question is, fit a binomial distribution to the above data, assuming that the coin are unbiased. Question clear? 6 similar coin are tossed 640 times with the following result: 0 number of head 7 times, 1 number of head 64 times, 2 number of head 140 times, similar. And the question is, we have to fit the binary distribution. Okay, so for answer part, we can say, look here, the coin is unbiased. So we have probability of head is P equal to 1 by 2. So its complement, probability of tail is Q, that is 1 by 2. And here number of coin is N, that is 6. So knowing this, as we know the recurrence relation for the probability of distribution as P of x plus 1 is n minus x divided by x plus 1 P by Q with P of x. Okay, and here you can see P equal to half, Q equal to half, so P by Q equal to 1. P by Q equal to 1. So we have P of x plus 1 is n minus x divided by x plus 1 with P of x. So the expected frequencies are calculated using what is used? It used that fx equal to n into p of x. Here capital N equal to 640. Tossing the coin 640 times. Hello. So p of 0 equal to 6 is 0, 1 by 2 is 0, 1 by 2 power 6. That is equal to 1 divided by 64. Now f of 0 equal to n into p of 0. That is n equal to 640 and the p of 0 is 1 by 64. So this gives 10. Similarly, you can compute for P1. P1 is 6 minus 0 divided by 0 plus 1 with P0. But this equals to, this gives 6 as 6 by 1 equal to 6 into P0. P0 equal to 1 by 64. Okay. Six by 64. Next, F1 give n into P of 1. That is n equal to 640 into P of 1 as 6 divided by 64. This gives 60. Knowing this, again you can go for P of 2. P of 2 as हम ये फॉर्मूला यूज करें, ठीक है. P2 equal to P of x plus 1 as n minus x by x plus 1. So P of 2 will be 6 minus 1 divided by 1 plus 1 with P of 1. So 6 minus 1 equal to 5 divided by 2 and P of 1 is 6 by 64. So this gives this equal to 15 divided by 64. Now knowing this, we can go for F2. F2 as n into P1, that is n equal to 640 with 15 by 64. This gives 150. And similar way, you can go for F3, F4, F5 and F6. Okay. When you compute, you can get F3 as 200, F4 value equal to 150, F5 value will be 60 and F6 value will be